Okay, good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, okay, I forgot to just mention a few things here, okay? I don't need to write them down, it's fine. Now, here, under alcohols, we also have the type of alcohols that we deal with, okay? We also have the type of alcohols that we deal with that are now. We also have primary alcohol, secondary alcohol, as well as tertiary alcohol. What will differ is that on an alcohol, instead of we'll say a carbon bonded to the, instead of halogen, we'll say to the hydroxyl group or the OH group is bonded to one other carbon. And then for secondary, it will be the same as secondary alcohol bonded to the OH is bonded to two, tertiary, it is bonded to that and that, okay? So yeah, it's just basically that. It's just basically that, okay? Then now, I want us to be in a position of saying, okay, let's look at the next type of organic compounds that we're going to be dealing with. Let's look at what we call an aldehyde. And on number 6, we have what we call an aldehyde. Okay? An aldehyde, it is one of a homologous, it is also a homologous series. Now, I want you to start saying now, okay, let's start from alcohol. The name is alcohol. The name is alcohol. Alcohol. Its name, it is hydroxyl. The name is alcohol, which is just the homologous series. Its functional group, it is what? Hydroxyl. So the name, which is homologous series alcohol, its name, it is hydroxyl. I want you to take it like that. Okay? This starts only from alcohol going down. Similarly here, I want to say its name, it is aldehyde. Its name, aldehyde. Its name, it is what? Its name is going to be the functional group, which is what? Formyl. Okay, this is what I want you to take note of. Name and name. Now let's draw the structure of functional group. This one is very unique. Why? Because now we say, okay, it's going to be now carbon. Okay, but that carbon will have double bond O as well as H at the end, then R. Okay, now what do I mean? Let me just enlarge this. What do I mean by this? This tells us, okay, this structure will always be like this. It's carbon, H, and O at the terminal carbon. Okay, these ones are always at the terminal carbon. This part, when we are dealing with aldehyde, this is always at the terminal carbon. The question is, what is terminal carbon? Terminal carbon, it is carbon number 1. It is always on the first carbon, okay? Then, whereas R can either be a hydrogen or an alkyl group, okay? So that is what we mean by the functional group, okay? Very important. The functional group, here is the functional group, double bond OH. So double bond H, this one, it is always on carbon number 1. Okay, this is what makes aldehyde special from the one that we're gonna draw in this is what makes aldehyde special from the organic compound that we're gonna talk about after this one. So we said now the functional group for this one. Functional group for this one, it is the formyl. Will be the formyl group. Formyl group. Okay, yes. Okay, Yes. So aldehyde wahamang waha-formyl. That one we had alcohol wahamang waha-hydroxyl. Okay. Now let's look at the general formula. The general formula for this one will be now, okay, we'll say, okay, we have CN, then we just need double of your hydrogens and then just one oxygen. Okay. Yes. We need carbon, then and one oxygen as well as whatever number of what hydrogens thereof. I'll show you when we now do the structure. Okay. Now the suffix. The suffix for ketone, can you guess it? Oh, sorry, this is not ketone. The suffix for aldehyde, can you guess it? Well, I would have wanted to say "ide," but no, instead we are going to take "al." We're going to take "al." Okay? It's going to be what, "al." Okay? Remember in alcohol, we took what? The last one, "all." On this one, you just take what? "al." Then now, let's come to naming. Naming what? Aldehydes. Huh? Is it aldehyde? Aibo. Yes, aldehyde. Now, what is it that we need to the precautionary measure? Prioritize. Prioritize the what? You prioritize the formyl group. What is the formyl group? The formyl group is this. HR. This is what you prioritize, okay? Yes. Another thing, no numbering. No numbering for aldehydes. No numbering for aldehydes. Why? Because always the functional group. Remember the reason we name it is because so that we see who the functional group it is on carbon number man, right? But in this case, aldehyde will always the functional group of aldehyde will always be on the what terminal carbon. Can you see that we said it is always on the terminal carbon? Okay, this what makes it different from the one we'll do. Let us draw. Let us draw this. The structure will always be something like this. Maybe something like H, H, H like that, H, H like that, C, H, H, H like that, H, maybe, yeah, okay. First thing first, I check functional group. It is what? It is this one. Where is it located? It is located on carbon number 1. So this one automatically tells me it is what? Aldehyde. You'll see on ketone, it is the same. This one is the same for ketone, but it is not on carbon number 1. Okay. For aldehyde, it is always on carbon number 1. Hence, we say it is what? So for aldehyde, it is always on carbon number 1. So hence, we say it is what? Aldehyde. So when we name this, the functional group, we do not need to name it, or it is on carbon number 1. It is always on carbon number 1. What we'll just name, let me say no numbering for, not aldehyde, no numbering for functional group. Functional group of aldehydes. So now when I name this, I'll say, okay, longest chain, I count from where? Obviously, I'll count from here because this one is always on carbon number 1. 2, if I went there, it was going to be 3. If I continued, it's going to be 3, 4. So, okay, this one is going to become my what? My okay, this is going to become my branch. So now, how do I start naming? I name the longest chain. It is how much? It is 4. It is butan. Butan. But what is the ending? The ending for aldehyde, it is al. Okay, so you're going to say, oh, this one means it's going to be butanal. Don't say butan 1 al. It is wrong. Why? Because We know for aldehyde butane, the functional group, which is al, will always be on carbon number 1, so we don't need to indicate that. Okay. Now we also met what CH3, which is a branch, methyl branch on carbon number 2. You'll just say 2 methyl, 2 methyl butanal. You are done. Okay, let's look at the other example, the last one maybe. We'll say, okay, if I have C, 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 okay, that means C, C, okay. It's been a while since we used ETH. Okay, it is not necessarily ETH, but it's fine. I'll just say 6, 1, 2, 3, 4, 5, 1, 2, 5, like this. I know this is double bond H. The reason I cannot include H here because it is already occupied C as 1, 2, 3, 4. Okay. Remember, double bond accept what? So oxygen can accept 2 bonds, so they are enough. So me putting a bond here will now breach rules because it will be 1, 2, 3, 4, 5. I don't want what I want 4. So I eliminate this one. Indeed. But here I need to complete H, H here, H here. I'm done. Can I name this? Let's see. Longest chain. Where's my functional group? This one is an aldehyde. It's always on carbon number 1. Good. So I start naming here 1, 2, 3. If I went there, it was going to be 4, 5. If I continued straight, it's going to be 4, 5. Can you see it is the same? So I can just remove this and continue with the longest chain. If I continue with the longest chain, can you see what is this? What is this? This becomes my branch. But what kind of branch? A branch that has how many carbons? 2. So this is what? Ethyl. You'll never have propyl, okay? So far you'll never have propyl. So now when we name, I say, okay, the longest chain, it is 5. Always it is whatever the longest chain, then al. Pentanal, propanal, ethanal, methanal, octanal, okay? So it is always pentanal, okay? Not pental. Pental does not make sense. Pental does not make sense. So it is pentanal, okay? You saying pentanal, I automatically know, okay, al, it is a functional group of aldehydes, and the aldehyde, it is always on carbon number 1. So, all right. Hence, now I do not need the numbering. But now I say, okay, on carbon number 3, I met what? An ethyl group or an alkyl group, which is a branch. Okay, so I'll say, okay, on carbon number 3, I had what? An ethyl. Done. 3-ethyl pentanal. Like that. I'm done. I'm done. I'm done. Okay. Special naming. Why? Because it does not have the numbering. But now when we go to this one that we look now, which now we refer to as a ketone, on carbon on number 7. Is it number 7? Yes. On number 7, we call this ketone. Ketone is just a homologous series, we know, right? And sometimes you need to draw the structure so that you see the homologous series they belong to. Okay. Okay. Now, let's be in a position of saying, okay, cool. We know this is ketone. Now, what is the functional group of this one? So this one is a ketone. It also has a surname. The name is ketone. The surname is carbonyl. You need to know this because they might ask you, what is the functional group of ketone? It is carbonyl. Okay? You just need to know them off by heart, unfortunately. Then this is ketone there, ketone. This is ketone. Let's look at the functional group of ketone. What makes ketone special? From alcohol, we know what makes alcohol special. It is OH. What makes aldehyde special is that the functional group is always on carbon number 1. But on this one, what makes it special? What makes it special here is that the the functional group, which is double bond O. Here also we had a functional group, which is double bond O. Do you see that? It was on carbon number 1. But here, the double bond O should be between carbons. Okay? Should always be between carbons. This what makes a ketone special as compared to aldehyde. Why? Because the double bond O here, it is between carbons, whereas the double bond O was on the first carbon. This should always be the first carbon, okay? This one should be between carbons. Can you see now the difference between the two? So now, this is what you draw when they say draw the structure of the functional group, okay? So this one, the functional group of this one, it is what we refer to as what? Ketone, wahamang, wahacarbonyl. Ketone, the same name of ketone, it is carbonyl, okay? So now the suffix here, let me just say between carbons, carbon atoms, always between carbon atoms. Now let's look at the suffix. Can you guess the suffix for this one for ketone? Are we gonna take cat, he, or own? Are we gonna take ne, own, tone, etone, ketone, or cat like that, or keto? Okay, what we're gonna take it is own. Ketone, end with own, okay, or one, but yeah, just call it own, okay. The general formula, nah. I did not forget the general formula. The general formula for aldehyde and ketone is the same. Okay? For aldehyde and ketone is the same. General formula is the same. CnH2nO. Now I want you to see, let's prove why are we saying now the general formula is CnH2nO. Now let's count here. How many carbons do I have? 1, 2, 3, 4, 5. I do not count only the carbons in the longest chain. I count every carbon I see. It is 1, 2, 3, 4, 5. So I say carbon 5. Then how many hydrogens do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. How many oxygens do I have? I have 1. Oh, okay. Does it follow the rule? Does it follow the rule? Yes, it follows the rule. Because why? Because for every one carbon, I have double of that hydrogen, then oxygen. Is it true? How many carbons do I have? I have 5. Then I will have double of hydrogens. 5 times 2, it is what? 10. Then then it means it is correct. Okay? This is what the molecular formula thereof. Okay? Yes. Now let's draw structures for this one. Okay? When you draw structures for this one, we should be very, 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 very careful thereof, because now we might find ourselves in a very, very serious danger. Okay? Yeah, there. Can you see I'm not putting hydrogen here, because why? This carbon already has 4. So yes, that's the reason thereof. Then now I will name. How do I name this? I'll say I want to prioritize the one that gives me. I prioritize the what? What's this? The double bond O, okay, which is a functional group. So I'll start counting from here. I'll see. I want to see. Okay. But what if I start counting from here? It is 1, 2, 3, 4, 5. Can you see now what I'm prioritizing? It is the same, whether I count from this side or this side. But the question is, which one should I take? Well, I check, okay, the aldehyde, the ketone, its functional group, whether I start counting from left or right, it has the same number. So let me look at the branch. Let me look at the branch. The branch is on carbon number mang. When I look at the red one, it is carbon number 2. When I look at the blue one, it is carbon number 4. So I want it to be on the small number, okay? So already I know my functional group, it is carbon number 3. My functional group, it is ketone. So I have, on carbon number 3, I have ketone own. This one I have to name. I have to give the what? The number of the position where I find my functional group, because if I do not number it, I'll just assume it is what? Aldehyde, okay? Then I'll say, okay, this one I have 2 methyl. I also have 4 methyl. Which one is the least? It is 2. So I'll take the one that has least, which is this one, the red one, okay? So it means now when I name this, I say, okay, the longest chain, it is 5. It is pent. But it's going to be pentan. What? On carbon number 3, I have a what? I have a functional group, which is what? Ketone. Remember, functional group of ketone, it is own. Why am I saying this ketone? Because the functional group here, it is between what? It is between carbons. Can you see? Is it true? Yes. The carbon that I'm talking, the double bond O, it should be bonded to, it should be at the middle of other carbons. Okay? The carbon bonded to the O, double bond O, should be bonded to 2 other carbons like that. Two other carbons like that. So this is the reason that makes me become sure that this is a ketone again. Then I also met a what? I also met a branch on carbon number 2. So I'll say, okay, on carbon number 2, I met a branch called what? Methyl. I'm done. Let's have the last naming for this one. Okay. Okay, we don't need difficult names for this one because, yeah, but it's fine. What if I just added BR here? H, let me say F, H, H, H here, H here, H here. Okay. Now let's be in a position of doing what? Of naming this one. How do I name? I name starting from where my functional group, double bond O, it is the smallest, where it is this side. Can you see? If I started from that side, it was going to be 1, 2, 3. So already it is big. So yeah, I just remove this. So it means I made a right choice. Then I do what? I say, okay, I do not have anything interesting. Rather, I have what? Oh, okay, longest chain, it is what? But. So I'm going to say it is butane. Remember I said from alcohol going down, it is no longer but, it is what? Butane. What? Position of the functional group, it is carbon number 2. Then what is that functional group? We call it is under ketone, we call it own. Okay, then now, what is it that we saw? On carbon number 3, we saw a what? A fluoro. So it's going to be 3-fluorobutane to own, like that. 3-fluorobutane to own, like that. So yes, that's all for aldehyde as well as ketone. Let's move on to the next one, where we now meet the what? We now look at carboxylic acid as well as ester. Okay, carboxylic acid as well as what? As ester. So yes, thank you very much. Join me on the next video so that you do not get behind. Okay, yes, thank you.